One of the ways that teachers can use modeling is they can have students draw a picture that represents their understanding of a particular concept or a particular idea at the very beginning of a unit, and then revisit that picture a little farther into the unit, maybe midway, and then even revisit that picture even one more time at the end of the unit right before a test. And what's really powerful is students can be asked to revise that model throughout the unit and keep adding to it as their information grows and their knowledge grows. And the other thing that's really powerful about that is it gives students a chance to really see how much they've learned and how much they've grown in terms of their understanding of a particular concept or idea over time. And that's a very powerful thing too. And it allows the teacher to really understand the depth of knowledge, the depth of understanding of a particular concept when they look at how detailed a picture or a model is. So for years in science we've been doing the carrying out investigation part, and we've gotten pretty good at that. The only problem is that the investigations we've been carrying out have been what I would call cookbook labs. They're very, very, very scripted. And what we know has been happening over time is kids come in and they're handed a lab sheet, and it's got all this detail. It's got these procedure, and it's got 27 steps in the procedure, and you're telling kids to read carefully and make sure you're following all the steps. And kids could actually get through the entire investigation, and you can look at a kid and say, okay, so can you just talk to me about what you did today and what you learned? And they'll look at you and not be able to talk about it, which is a really scary thing, but we've seen that happen time and time again. So we're trying to change the focus into just the carrying out investigation to really engage them in the planning process. So giving them an opportunity to think about a concept or think about an idea or think about a question that they've come up with, and how would they go about answering that question? What kind of information would they need? Constructing explanations is in a sense a lot like the old, can you write a conclusion for a laboratory that you did? But NGSS takes it to a much deeper level, and it's about asking students to take information and analyze it and synthesize it in such a way that they can come up with an explanation. And that doesn't necessarily mean, the conclusion in a lab. It can be the explanation about any kind of phenomena that they see. One of the things that we're trying to really build on is this constructing explanations and using solid evidence to construct these explanations, and teaching students the difference between an explanation and an opinion, for example, and really taking them through the process of taking something that they think they understand in their head and really articulating that in some way. So the explanation could be a written explanation, it could be a visual explanation, they can make a model of something. So there's lots of ways that you can construct an explanation, but it's about an organized group of ideas that make sense to the observer. So if you're designing a solution, the first thing is you always want to go back and tie it to what the problem is that you define. So you want to make sure that the solution matches the problem. And in engineering, a lot of engineering is about improving something. Well, you don't just want to say, I just want to improve this. Well, what specifically do you want to improve? So if we want to improve the battery power of a cell phone, that's something specific. So then our solution would have to include something like the chemicals that are used in the battery and the life of the chemicals, or how long the chemicals will react in order to give us a longer lifetime. So you've really got to go back and match up your solution with your problem and really make those ties to see if there's that connection that you're looking for. I taught for 18 years, and we would have 50 minutes in our class period. And when you think of, okay, so the first 5 minutes is taken up with attendance and whatever nonsense has to go on. You're trying to explain to the kids what to do. They finally get engaged in the activity and they spend all their time doing the activity. And then all of a sudden, the bell rings, it's the end of class, and as they're packing up their stuff, I'm yelling at them, okay, everybody, make sure you fill in the data table and answer those questions and bring your lab back tomorrow all completed. And what we never did a good job of is the analyzing part. We spend all of our time in the science classroom collecting the data. So we'd spend the whole class time collecting. And that's the fun part. That's fun. That's a very doing part, right? So kids are taking measurements, they're watching something happen. That's cool to see, but that's meaningless if you don't spend the time helping them analyze and make sense of what the data is telling you. So what we're trying to focus on now is let's not just spend time collecting the data, or at least let's spend as much time analyzing it as we have collecting it. So instead of telling kids, finish the graph, finish the table, answer those questions, be ready to turn in tomorrow, what we're saying is, come back tomorrow, we're going to talk about what the data means. We're going to take a look at it 3 different ways. How about each group comes up with a way to represent the data, and let's share that when we come back and see how each of us saw a way to make the data meaningful to us.